Differentiation for engineers covers a huge variety of topics. We can look at velocity, acceleration, because what differentiation does is it talks about change in one variable with respect to another. So we can talk about velocity as being change in distance with respect to time, and acceleration as the change in velocity with respect to time. We also can use differentiation to find the maximum value of some function, or conversely the minimum value of some function. When we're looking for rates of change, we do need to differentiate, between the types of functions that we've got. If we've got a straight line, if we've got a linear function, then the gradient is going to be constant, and we can use the formula that we've used before that says m equals the change in y over the change in x. That's not new. But if the line is not straight, the gradient of the curve, I've got a curve like that, if we're just going to take 2 points like that, the gradient of that line will give us the average rate of change. And it's that we need to look at to start off with. Let's look at the second of these questions. Let's look at the voltage question. And let's look at the first one. It says we need to find the average rate of change of the voltage as time varies from t equals 0 to t equals 2. So first up, we need to find when t equals 0, we need to find the value of V. And we need to find when t is 2, we need to find that the value of the voltage is 3.2706. Once we found those values, then it's a matter of putting them into the rule for m. Remember, we're finding the average value here. So it would be 5 minus 3.2706 divided by 0 minus 2, and that gives us an average rate of change, or the slope of the line that's joining those 2 points, as negative 0.8 something. Right, that is to find the average rate of change. What we've done there is we've found the gradient of the chord that's joining those 2 points, the chord that's joining AB, and that gives us an average rate of change. Now, average rate of change is all very well, but really we need to find the instantaneous rate of change, and the only way we can do that is to look at it so that instead of these 2 points being a long way apart, what we do is we bring the second part closer, and the second point closer and closer to the first one. So then we say that the slope of a curve is going to be the limit, or the limiting value, as x2 tends towards x1, so that these 2 points here getting closer and closer together of that fraction. So then we find that we've got the slope of the tangent to the curve rather than the slope of a chord, which is what we've got in the diagram here. So this is the official story, this is the background, this is where all this differentiation idea has come from. You're not going to be asked to work these sort of things out, but it is a good idea to know where the information has come from. You can see in this diagram, if we were to try and find the slope of the curve, first of all here the slope is negative, over here the slope is positive, but say at this point here, the nearest we can get is to find a tangent to the curve and find the slope of that. Again, this is just a theoretical type of function 2x minus 4 over x plus 1. And we did look at a bit of this when we were looking at drawing graphs and drawing log graphs in particular, because this graph, this function has got a problem, and that x can't equal -1, because if it does equal -1, then it's undefined. So what we need to do is we need to look at what happens as x tends towards -1 from this way and this way. And we also need to look at what happens as x gets bigger and bigger and bigger, and as x gets smaller and smaller and smaller. So if you look at the number crunching that's gone on, this is just an Excel spreadsheet, that as you go from 1 up to 1 and a lot of zeros, the fraction tends towards 2. And if you go towards -infinity from -1, then again, in the limit, that fraction looks like it's coming towards 2. So there we could say that the limit is 2. And if you look at the picture, both parts of the graph are actually heading up towards 2. There's 2 there. So the right-hand part of the graph is tracking up towards being y equals 2, and the left-hand part of the graph is tracking down to being y equals 2. A little bit technical here. In order to be able to do this thing that we call differentiation, we have to know that the function that we're talking about is continuous. So something like this we can differentiate, something like this we can differentiate. As long as the corner is not too sharp, we can differentiate it. We can't differentiate, so we can differentiate that and that. But if we've got something like this, where we've got a gap in it, we can't differentiate it because it's not continuous. If we've got a function where it comes up, and then for some reason it can't have that value and then it continues, that's not differentiable because it's got a gap in it. And similarly, a piecemeal function, like this, where it comes up to there, but it doesn't include that number, and from that number onwards, it's down there. That also is not differentiable because it's not continuous. This, you can think about this. All you need to do is think about a graph. There, the slope is not continuous. The gradient, the slope is changing as we progress through. What we need to do in the rest of this section is to find a way of measuring the gradient as it changes. And this is the process is called differentiation. And what we do is we find the equation of the tangent, which sometimes we call the gradient function, and then we use that to find the rate of change at a particular point. Now, something that you really need to remember is that if we are talking angles, then all angles need to be in radians. So we talk about the rate of change at a point being the gradient of the tangent to the curve at that point, and we're going to be able to write it in lots of ways. We're going to write it as dy by dx. We're going to write it as perhaps f dash. We're also going to write it as d by f of x over dx. We're going to call it the derivative, we're going to call it the gradient function, we're going to call it the differential coefficient. This process of finding the derivative is called differentiation. Now, mostly, as far as this course is concerned, mostly you're just going to look up the gradient function in a table. Sometimes it might be quicker and easier to start learning a few of them, but otherwise you'll be looking it up in a table, and you'll be given a limited table of derivatives in the exam. So in summary, the derived function, or the derivative, gives the value of the slope of the curve at a point. There is a general rule that we will find very, very useful, and it covers a lot of the functions that we might look at. If y is equal to, say, 3x to the power of 4, then the derivative is equal to 4 times 3 times x to the power of 4 minus 1, which we could rewrite as 12x to the power of 3.